Okay, hello again. This is the third chapter on chemical formula and equations. We're talking about basically how to write chemical formula. You should know how to write chemical formula at this point, but let's go over the basics. We know that to write a chemical formula, the first thing you do is write the symbols for each element and then put the valency of one under the other. Now, what do we mean by valency? Well, if something is in group 1, it has 1 electron in its outermost shell, so its valency is 1. Anything in group 2 has 2 electrons in its outer shell. It needs to lose these 2 electrons to be complete, so the valency is 2. Anything in group 3 has 3 electrons. It needs to lose these 3 electrons, so we say the valency is 3. Anything in group 4 has a valency of 4. Now, anything in group 5 has 5 electrons in its outermost shell, and we said if it has 5 electrons in its outermost shell, it needs 3 more to be 8, which is the complete shell configuration. So if it needs 3 electrons, that means its valency is 3. Anything in group 6 needs 2 electrons, so its valency is 2. Anything in group 7 needs 1, so its valency is 1. And then we said there are some things that you cannot get from the periodic table. So things like hydroxide, nitrate, nitrite, hydrogen carbonate, ammonium carbonate, sulfate, phosphate. Remember that you should know the formula of each one and the valency. Now, phosphate is the only one with a valency of 3. So phosphate, anything phosphate is PO4 with a valency of 3. Sulfate and carbonate have a valency of 2, and everything else has a valency of 1. This needs to be memorized if you have not already memorized it for the O-level course. We know that transition metals, usually they have more than one valency, so usually you will be given the valency by putting it between brackets. So for example, if I say iron 2, that means I'm talking about the iron that has valency 2. Iron 3 is the one with the valency 3, and so on. Copper is usually 2, silver is usually 1, and zinc is always 2, so no one is going to tell you the valency of zinc. You should know it's 2. Okay, so for example, to write the formula of sodium oxide, we said what is the rule? Write the symbols and then the valency of one under the other. So sodium oxide, sodium is Na, oxide, anything iod is what you have in the periodic table. So oxide is O, chloride is chlorine, fluoride is fluorine, nitride is nitrogen, and so on. So oxide is O. Now the valency of sodium, sodium is in group 1, so its valency is 1, so I don't write anything under the O, the 1 is understood. Now the valency of oxygen is 2, so I have to put 2 under the sodium. Magnesium chloride, magnesium is Mg, and chloride is chlorine, Cl. Now, Mg is in group 2, so that means it has a valency of 2. The 2 goes under the chlorine, not under itself. The chlorine is in group 7, it has a valency of 1. We don't write anything under the magnesium. Ammonium, how do we write ammonium? Ammonium is NH4. Chlorine has a valency of 1, so I don't put anything under the ammonium. The ammonium is NH4 as it is. If I were to write something under it, I would put it between brackets, but since chlorine has a valency of 1 and ammonium is 1, then you don't write anything. Now, to write the formula of acids, remember that any acid starts with H. So hydrochloric, nitric, sulfuric, phosphoric, carbonic, whatever, they start with H. And then you should realize that hydrochloric is the acid that has chlorine. Nitric is the acid that has nitrate. Sulfuric is the acid that has sulfate. Phosphoric is the acid that has phosphate. Carbonic is the acid that has carbonate. And then you put the relative valency of each one under the hydrogen. Okay, sometimes the name indicates number of atoms. So if he says something monoxide, that means you just put one O next to it and you ignore the valencies. So nitrogen monoxide, I give the nitrogen 1 oxygen and I don't think about the valence. I don't say what's the valency of nitrogen, what's the valency of oxygen, because that will mess it all up. This is an exception. When we say monoxide, you just give it 1 oxygen and that's it. Forget about the valency. Dioxide, you give it O2. That's it. Don't think about the valencies. Trioxide means 3 oxygens. tetra something means 4. So carbon tetrachloride means carbon with 4 chlorines, and you do not apply the rule of valencies to this. Okay, so let's write chemical formula very quickly to remind us. How do we write sodium hydroxide? Again, sodium is Na and hydroxide is OH. The valencies of each of them is 1. So this is how you write sodium hydroxide. Potassium iodide, this is how you write it. Lithium carbonate. Can you write lithium carbonate? The valency of carbonate is 2, so I have to put 2 under the lithium. Sulfuric acid. How do you write sulfuric acid? We said acid starts with H. Sulfuric is the one that has sulfate, and the valency of sulfate is 2. Copper 2 chloride means copper that has a valency of 2, so the 2 goes under the chlorine. Aluminium sulfate, well, valency of aluminium is 3, it's in group 3, so you have to put 3 under sulfate, and we said if you put a number under these groups, you have to put them between brackets. So sulfate, bracket 3, sulfate, valency 2, so you put the 2 under aluminium. Iron 3 oxide, the valency of iron is 3, so the 3 goes under the oxygen. And valency of oxygen is 2, that goes under the iron. Remember, the valency of something goes under the other one. So when I say iron 3, I mean the iron has a valency of 3, that means the 3 goes under whatever is next to it, not under itself. Calcium sulfate, calcium has a valency of 2 and sulfate has a valency of 2. Now if they both have the same valencies, they cancel each other. So instead of putting 2 under calcium and 2 under sulfate, they cancel, so I don't put anything under each of them. Zinc phosphate, the valency of zinc we said is always 2. Zinc is 2, phosphate is 3. The 2 goes under the phosphate and the 3 goes under the zinc. Remember all of this? Good. Balancing equations, remember that we said to balance the equation, you write the formula of each of them correctly, and then you need to balance it so that the same number of atoms on either side of the arrow. And then if he's asking for a state symbol, then you should realize that something that's solid, you put an S, liquid, L, G, gas. Now, anything dissolved in water is aqueous. So remember that when you're putting the state symbol for water itself, water is a liquid. But anything dissolved in water is aqueous. So you put AQ under it. Okay, so, and remember again that some molecules are diatomic when we put them in the chemical equation. If they're standing alone, they must have a 2 under them. So if I say something plus hydrogen, then hydrogen is H2, not just H. Something plus nitrogen, N2, plus oxygen, and so on. So which ones are diatomic? Hydrogen, nitrogen, oxygen, fluorine, and everything under the fluorine. Chlorine, bromine, iodine. So let's write balanced equations for these. We write the formula of each one, and then we balance them. So nitric acid, again, nitric acid is HNO3. Calcium hydroxide, to give calcium nitrate plus water. Remember that even if he doesn't tell you to balance, a symbol equation has to be balanced. You cannot write a symbol equation without balancing. How do we balance? We count on both sides of the arrow. So in this case now, I have already balanced it, so that means I have 2 hydrogen before the arrow. I have 4 hydrogens before the arrow. I have 4 hydrogens after the arrow. Can you see that? Do you remember how to balance? You count before the arrow and after the arrow, and you increase the one that is less. So this one, barium chloride plus sulfuric acid. Can you try balancing it and writing the formula? Well, you should end up with something like this, right? Okay, so let's take a look at this question. Okay, how do we write ionic equations? To write ionic equations, you need to write the balanced equation, and then you cancel whatever is the same on both sides of that. So let's write this. So we're saying copper reacts with silver nitrate. So you should know that this should give you copper nitrate plus silver. Now, which ones are solid, liquid, gas, or aqueous? You should realize that all metals are solid. So copper is a solid and silver is a solid. Now, silver nitrate, you should remember that anything nitrate dissolves in water. So anything nitrate is aqueous. And anything that is aqueous is ionized. So first of all, we balance. So this is how you balance. Before the arrow, remember again, how do we balance? Let's go through this again. How many copper before the arrow? 1. How many copper after the arrow? 1. Now, how many silver before the arrow? 1. How many silver after the arrow? 1. Now, how many nitrogens before the arrow? Before the arrow, I have 1 nitrogen. But after the arrow, whatever is outside the bracket applies to everything inside the bracket. So how many nitrogens do I have after the arrow? I have 2 nitrogens and 6 oxygens. Can you see that? The 3 under the oxygen applies only to the oxygen, but the 2 outside the bracket applies to everything inside the bracket. So I have 2 nitrogens after the arrow, so I need to fix this so that I can have 2 nitrogens before the arrow. But that means that now I have ruined the silver, so I need to balance the silver, and now everything is balanced. Now I ionize whatever is aqueous, so the metal remains the same, but the aqueous is ionized, so silver nitrate is actually Ag plus and NO3 minus. I had a 2 before them, it still remains. Now the copper nitrate is aqueous, so I have copper ions plus nitrate ions. Anything that's a solid, liquid or gas remains the same. Now I find that I have NO3 before the arrow and NO3 after the arrow. I can cancel them, so my net ionic equation is this. So which one is correct? A. Do we understand that? Okay, so ionic equations involving electrons. Remember we did this before. If I have a positive, in order to become an atom, it gains electrons. So I have 1 H before the arrow, 2 H's after the arrow, so I have to balance that with 2 H's, and that means that now I have 2 positives, so I need 2 electrons to balance them. Now the zinc 2 plus needs to gain electrons in order to become zinc, so I put 2 electrons, so now I have 2 positives and 2 negatives to balance each other. The negative ions lose electrons, so Cl minus will lose electrons, and when it loses electrons we need to balance the atoms and we need to balance the charges. So if I have 1 Cl before the arrow and 2 Cl's after the arrow, I need to put 2 before the Cl minus. And that means that now I have 2 negatives, so I end up with 2 negatives on the other side. OH minus, when you sit down and balance it, you'll find that we have to balance this in order to balance the number of electrons and the number of atoms. Okay, now once we have individual ionic equations, I can add them all up in order to have an overall ionic equation. So if I have these, I need to balance each of them and then make the number of electrons the same and then add them all up. You remember this? Okay, let's try this. So the first equation, I have 2 chlorines before the arrow, so I need 2 chlorines after the arrow. That means that now I have 2 negatives, so I need 2 negatives. Right? So that first equation is balanced. Now that second equation, is it balanced or not? Well, I have 1 iron before the arrow, 1 iron after the arrow, so that is fine. Now the positives, 2 positives before the arrow. After the arrow I have 3 minus 1, so that's 2. So that second equation is balanced, but then if I want to add them all up, the number of electrons must be the same. So I need to multiply that second equation by 2 so that I end up with 2 electrons in each of these equations. Then they can be cancelled. So what I have is an overall Cl2 to Fe2 plus to give 2Cl minus plus 2Fe3 plus. Can you see what we did? Okay, let's try another one. Okay, let's try balancing this. So before the arrow I have 2 bromines, so after the arrow I must have 2 bromines, so I put a 2 there. Okay, that means now I have 2 negatives after the arrow, so I need 2 negatives before the arrow, so that's balanced. Now the other one, I have 1 iodine before the arrow, 2 iodines after the arrow, so I need 2 there. That means now I have 2 negatives, so that's 2 negatives. And the number of electrons on both sides are equal, so I can cancel them directly and just add up the equations. Everything before the arrow gives everything after the arrow. Do we understand this? Okay, try doing this one. Okay, so how many manganese before the arrow? 1 manganese before the arrow. After the arrow, 1 manganese. Not the positives. We're not adding the positives. We're adding how many Mn. So 1 Mn before the arrow, 1 Mn after the arrow. Now, how many H pluses? I have hydrogen, 1 hydrogen before the arrow. I have 2 hydrogens after the arrow. And the oxygens, in order, before I balance that, I have 4 oxygens before the arrow, so I must have 4 there. And that means I need 8 hydrogens, so that is 8H plus. Now, after the arrow, I have 2 pluses. So that means that before the arrow, I should have a total of 2 pluses. Now, I already have 1 negative on the MnO4, and I have 8 positives, so that is 7 positives. So how many electrons should I have in order to end up with 2 positives? I need 5 negatives, right? Okay, the second one. I have 2 hydrogens before the arrow, 2 hydrogens after the arrow now. Oxygens are balanced. Now, that means before the arrow I don't have any charge, so after the arrow I must have a total of 0 charge. Okay, problem. One equation has 5 electrons, the other equation has 2 electrons. So how can I make them the same? Well, I can multiply the second one with 5. Okay, and that means that I end up with this. And I multiply the first one with 2, so I end up with this. And in that case, now I have the same number of electrons, so I can cancel them. And whatever is the same on both sides, I should subtract them. Okay, I have 2 MnO4 minus plus. Now, how many H pluses? Well, before the arrow, I have 16 H pluses. After the arrow, I have 10. That means I have a total of 6 H pluses. Plus the 5 H2O2. On the other end, I have 2 MnO2 plus, 8 water, 5 oxygens. Do we understand what we're doing? Okay, let's try this one again. So, 2 chromium before the arrow, so I need 2 to balance the chromium. Now, 7 oxygen, so I need 7 there, and that means now I have 14 hydrogens after the arrow, so I need 14 hydrogens. Now, the positives on after the arrow are 2 times 3, so 6 positives after the arrow. So I need a total of 6 positives before the arrow. Now, I already have 2 negatives on the dichromate, on the Cr2O7. 14 H plus, so that means I have 12 H pluses. Now that means I need 6 electrons so that I can have 6 pluses on both sides of the arrow. Okay, the other one, 1 copper, but I have 2 positives, so I need 2 negatives. Now, to make the electrons the same for both equations, I multiply this one by 3, so that comes out to be 6 electrons, and I can cancel them. And then I just add everything before the arrow to give everything after the arrow. Okay, this is another one. The dichromate is balanced in the same way. Now the C2H5OH, I should need 4 H pluses, so that means I need 4 electrons. Now, what do I do to make them the same? I can multiply the first equation by 2 and multiply the second equation by 3. So in that case, I will end up with these overall equations. Are we okay with all of this? Okay. So we cancel, and that's the total overall reaction. Okay. This one again, 1 nitrogen, 1 nitrogen. I have 3 oxygens on after the arrow. I already have 1 on the NO, so I put 2 for the water. That means I have 4 hydrogens, 4 H pluses. Now 4 H pluses, and I already have a negative on the NO3, so that is 3 H plus, so I need 3 electrons to balance. Now the second equation is already balanced, but then I needed to have the same number of electrons, so I need to multiply everything by 3 so that I can cancel the electrons and add up everything to give the overall equation. Okay? Okay, and that's the end of this chapter. Please study all of this, go over it, and try the questions. and then we'll meet in the next video. Thank you.